Today we're going to talk about Chapter 4, Lesson 5, Page 2, where we compare properties of functions. And again, in my opinion, the best way is to actually write the equation and compare the two equations because it puts the numbers right where you need them, right in front of you. So let's look at problem number 1. It says that Anne kept track of her steps. And she has an equation of y equals 700x. So that's y equals 700x. And it says the table below shows the number of steps per hour that Elise walked. So, okay, we're talking we need our rates of change. And notice, too, that for Anne, that there is no y-intercept, because it's kind of impossible to have taken any number of steps before you started. So, the day starts and you start counting your steps, so it's not like you can carry over steps from the day before. You took however many you took today, and that's it. And then, you stop counting and you start a new day. So it's not like there's going to be a new starting value. There's not going to be a starting value every day. It's always going to be, you're going to start the day off with 0 until you take your first step. Okay, so so this equation is a direct variation equation. It isn't asking about that, but I want to make sure that I point it out. That's how you can tell. Problem number 1, again, we're going back to Elise, and she's going from 575 to 1150. And again, I just want to take out my calculator and verify the number. I believe it's going to be 575, but let's make sure. It's 1150 minus 575. So this number changed 575 steps. And then 1725 minus 1150 is again 575. And then these numbers are clearly 1. So our slope for Elise is 575 over 1. So her equation is y equals 575 steps per day. So compare the functions for each person by comparing the number of steps. It appears as though Anne's taking more steps. In fact, Anne is taking 700 minus 575. Anne is taking an extra 125 steps per day, according to the information that they disclosed here. So that's it. That's the answer to number 1. Anne is walking more by 125 steps. Let's look at problem number 2. It says the graph shows the outside temperature after a number of hours, and the inside temperature after X hours can be represented by the function. So what they're doing is, again, they're giving us 2 sets of data. They're giving us the inside temperature is 68x, and we need to look at the outside temperature. And they only gave us 1 data point. So the x changes 1, and the y changes from 0 to this 71. So our change in y is the 71, and our change in x is just 1. So our equation is 71x. And so compare the two numbers. Well, it looks as though it's warmer outside than it is outside by 3 degrees. Duh. Okay, that's it. That's all you got to do for number 3. Oh, I'll write it down. It is warmer outside by 3 degrees. And that's it. That's all you got to do. Well, let me, if I could write, I'd be a bit dangerous. It's warmer outside by 3 degrees. That's it. Okay, now let's take a look at problem number 3. For every computer that is sold, Kendall receives $250 in commissions. The amount of commissions that Peter receives can be represented by the function 225x. How much more does Kendall receive in commissions than Peter if they both sell 5 computers? Well, Kendall's equation is y equals 250x, and Peter's is y equals 225x. And so there's two ways of doing it. You can say that 5 times 250, and then subtract the 5 times 225 equals, right? Or an easier way of doing it is to say that the difference between 250 is 220 and 225 is $25 per computer. So quite simply, Kendall's making $25 per computer more than Peter. So if they want to know how much more she makes, it's easier to create this equation, the difference in how much they make, and do the calculation for 25 times 5 is $125 more for Kendall. And that would be the answer to number 3. Number 4, a new car gets 33 miles per gallon of gas. The graph shows the number of miles, Y, that an older car gets per gallon of gas. Compare the miles per gallon for each car. So a new car gets 33, so Y equals 33 per gallon. So let's make that X, just for the sake of argument. And then the graph shows the number of miles that an older car gets. Well, let's see here. This number is changing 3, and this number is changing 81. So our slope, our change in Y over our change in X, is going to be 81 over 3, which is 27. So the older car gets 27 miles per gallon, and so you can see that the new car gets 6 gallons per gallon better mileage. And that's it. Gets better. The new is better. And that's the answer to number 4. And if you have any questions, let me know in class. And let me recenter it and save the video.